Good afternoon, everyone. Welcome to all of you. I'm Kumar Ravi, and I welcome all the students at Exampur English Medium Prep YouTube channel. Yes. Okay. So, guys, as we have already discussed the three chapters of the general physics portion, and we are now heading to the fourth chapter of the physics, and that is gravitation. Okay, so here it is written as the chapter number 6, so don't worry that in your batch I'm teaching it as a fourth chapter actually. Okay, so don't worry about that. So today we will start gravitation. Gravitation is a very important chapter, and there are many important questions which are asked from this chapter, and we will discuss one by one each concept behind the concept. Okay, so let's start about the gravitation. You know that gravitation was first told by the Isaac Newton, as it is said that in books. Okay, so actually according to the Indian history, that Indian scientists were the first, but actually he failed to write down all the things. Okay, that's why when the Newton came into the existence in this world, and he explained about the gravitation, then everybody just accepted because he was able to read, write. Okay, so he has given some data, and that was the reason that the data is always accepted by everyone. If you just say that it happens, nobody will going to accept all these things. Okay, so whenever you speak anything, just if you present some data, then obviously then the people will believe, and they just note it down for the future reference. The similar thing happened in case of gravitation and the Isaac Newton. So here when we talk about the gravitation, we say that earth attracts each and everything. Earth attracts each and everything towards it by an unseen force of attraction. Okay, so earth attracts each body towards it by an unseen force of attraction. As I have already told you that the earth attracts each body towards its center by some force, and this force is actually attraction force. Okay, so this force is also known as the gravitational force. Not only the earth, in this universe, everything in this universe, each and everything attracts each other. Okay, suppose that these are the two things, one is knife and the another is pen, and these two things are also attracting each other. Okay, these two bodies are approaching, trying to approach each other by some force. Okay, there is an invisible force actually. There is an invisible force. Okay, so this kind of force is known as the gravitational force. Any two bodies in this universe attract each other. Okay, when we talk about the earth and moon, there is an attraction force. When we talk about the sun and earth, there is an attraction force. Okay, so there are all the in this universe, every two bodies. Okay, any two body, you just pick up any two bodies and you just start analyzing then you will find that there is an attraction force between these two bodies. Actually, that attraction force is known as the gravitational force. Okay, so this force of attraction is known as the gravitational force or gravitational pull. Okay, so always remember that gravitational force is always attraction type. One thing I would like to write here, that gravitational force gravitational force is always attraction type. Gravitational force is always attraction type. Okay, gravitational force cannot be repulsion type actually. Okay, so gravitational force cannot be repulsion type. So universal law of gravitation, when we talk about the universal law of gravitation, actually Newton has given the universal law of gravitation, and this is known as Newton's law of universal gravitation. Okay, so this is also known as the Newton's law of universal gravitation. 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 Okay, so here if we ask if we talk about the Newton's law of universal gravitation, as we have already told that any two bodies in this universe attract each other, okay, by some value of force. Okay, but this attraction force depends upon the two things. Number one, the masses of the two bodies, those who are attracting each other, and the separation between these two bodies. Okay, and the separation between two bodies. So we can see that the force of attraction is directly proportional to m1 and m2. Actually, these two bodies whose mass is m and m. Okay, suppose that this is the mass of these two bodies is small m into capital M. Actually, these two bodies are attracting each other. So the attraction force between these two bodies, attraction force between two bodies, okay, attraction force between these two bodies depends upon attraction force between these two bodies depends upon the masses of these two bodies and the separation of these two bodies. Okay, and this F is inversely proportional to R square. Okay, so if we combine these two things, if we combine these two things, okay, if we combine these two things, F becomes m1 and m2 upon R square. Okay, so F will becomes equals to capital G into small m into capital M upon R square. Okay, so this is the formula to calculate the attraction force. This is the formula to calculate the attraction force, and this capital G, and this is a proportionality constant. This is a proportionality constant. This is known as universal gravitational constant. Universal gravitational constant. Universal gravitational constant. Okay, so guys, note it down. Okay, so guys, this is the formula to calculate the attraction force between the two bodies having masses small m and capital M. Always remember one thing, that this force, value of this force is always equal in case of that. Okay, this mass M realizes the same value of attraction force as this mass also realizes the same value of attraction force. It doesn't mean that the attraction force acting between these two bodies will be higher in case of the mass capital M, and will be smaller, the value will be small in case of the small m. No, it doesn't. Actually, the attraction force acting between these two bodies acts the same with the same value on both of these two bodies. Okay, it means I want to say that this force, suppose that this is a mass, suppose that this is 5 kg, okay, and here this is a mass of 10 kg, okay, and these two bodies attract each other. These two bodies attract each other with some force. Suppose that the attraction force between these two bodies is 10 Newton. Okay, then this body will also realize the force of 10 Newton, and this body will also realize the attraction force of 10 Newton. Okay, so I want to say that this is the conclusion here. Okay, so the distance between these two bodies is always measured. The distance between these two bodies is always measured from the center of this body to the center of this body. Okay, so Now again, this is okay. Here in this diagram you can see that these two bodies has been taken. Okay, I have done this derivation. I have already told you about the capital F, the attraction force. This is equal to capital G into small m into capital M upon r square. Okay, so guys, suppose that if this distance, yeah, value of this capital R increases, then the value of the force decreases. Okay, if the value of the masses of these two bodies increases, if the value of the masses of these two bodies increases, then the value of the force increases. Okay, and this is the formula. Okay, and this is the formula. Okay, so here we can say that force of attraction depends upon these two bodies. Number one, the mass and the separation between these two bodies. Sometimes in government job exams, the unit of gravitational constant is asked. This is capital G, and capital G can be calculated as F into R square, upon small m into capital M. Okay, so the unit of capital G can be calculated like this. Force, attraction force, this is Newton. Attraction force, this is Newton into R square means meter square, upon kilogram square, Okay, so these are the units. Okay, so this is the unit. Okay, now importance of the universal law of gravitational. It binds us to the earth. Okay, actually these points I have already told you. It binds to the earth. It is responsible for the motion of the moon around the earth. Guys, if there were no attraction force between the earth and the moon, then we can say that the moon could not have been moving around the earth. Okay, due to the attraction force between earth and moon, the moon is at a fixed distance. Moon is at the fixed distance with the earth. Okay, and moon realizes a force during motion around the earth. During motion around the earth, the moon experiences a centrifugal force. Moon experiences a centrifugal force like this. Moon experiences a centrifugal force like this. If this moon is moving like this, okay, with the orbital velocity v, then this is the attraction force. This is the attraction force between earth and moon. This is the attraction force, gravitational force, and this force is centrifugal force, and this is centrifugal force. So during motion around the earth, this moon realizes two forces. Number one, centrifugal force, which is actually pseudo force. Okay, and this force is balanced by the gravitational force. That's why the separation between earth and the moon remains constant. Otherwise if centrifugal force doesn't work, then the moon will fall on the surface of earth. Okay, then the moon will collide with the earth, or similarly the other satellites will also collide with earth, or other satellites who are just circulating about other planets, they will also collide with they will also collide with their planets. Okay, in the similar way, this earth is rotating around the sun. Okay, this earth is rotating around the sun. Okay, suppose that this is earth, and this earth is also moving around the sun like this. This earth is moving around the sun with velocity. Okay, and the separation between these two bodies is this, and the separation between these two bodies is this. Okay, now this earth also realizes an centrifugal force like this, and this earth also realizes some attraction force. This is Fg. Okay, so this force of attraction is balanced by the centrifugal force, and hence this is the reason that earth always keep on moving at the same distance, with the same distance, okay, and due to this earth does not fall into the sun. Okay, so this is the reason. The gravitational and gravitational attraction force is the reason for the tide also. Okay, when the moon come near to the surface of earth while moving around the earth, then the attraction force, and then due to the attraction force between moon and the ocean water, the ocean water rises upwards, and then when the moon goes away, then the attraction force decreases, and then the ocean water falls down. Okay, and this is the reason behind the tide also. So it is responsible for the motion of planets around the sun. Okay, similarly, gravitational force of moon causes tides in the seas on the earth. Okay, so all these things happen just because of the gravitational force. Okay, now free fall. When we talk about the free fall, this is a very important topic, guys. This topic is asked in the many examinations. You will find at least one question: free fall. What is free fall? Actually, whenever we talk about the free fall, when suppose that there are two methods by which we can send this body from this position to the ground. Okay, one is we will force it to go like this. Okay, we will throw like this, but one is we have to just drop it like this. Okay, when we drop anything like this, then it means you are not throwing anybody towards the earth. Okay, when you don't throw anybody, when you don't give any initial body to the towards earth, then it is known as the free fall. Okay, you will just drop that body. Drop means the initial velocity of the initial velocity of the body is 0. It means this body will fall under gravity. This body will fall under gravity. This body will fall itself. This body will acquire its velocity on. You will not give any velocity to this body. And when this body falls freely, this body moves under gravity. And this body moves under gravity. And the acceleration of this body during the free fall is always equal to gravitational acceleration. Okay, so when an object falls from any height under the influence of gravitational force only, this is known as the free fall. In case of free fall, when the body is dropped, drop means the initial velocity is 0. Okay, suppose that this is a building. Suppose that this is a building like this. Okay, suppose that this is a building like this, and this is a building like this, and you apply force like this. Suppose that, and you apply force like this, and this body just falls down, and this body just falls down like this. U is equals to 0. U is equals to 0. Okay, initially the velocity of this body is equal to 0, and then this body falls under gravity with the acceleration g. Okay, and this g is known as the gravitational acceleration. So always remember, this question is always asked, that when the body falls freely, what is the acceleration of the body? Then always remember that when the body falls freely, then the acceleration of the body is always equal to small g. Is always equal to small g. Okay, so this one is very important topic actually. Okay, guys, if you are watching this lecture live, then please do comment and let me know if you have any doubt. Okay, so I will make your all doubts clear. So this is the free fall. Okay, suppose that you are suppose that you have gone on any tower, okay, with your friends, and one of your friend just pushes you so that you starts falling towards the ground, then you will fall freely. Okay, and suppose that you are very smart and you have a parachute, then you will open your parachute, and then you will come down to the earth very slowly. Okay, so then your life will be saved. Okay, so acceleration due to gravity. I have already told you about the acceleration due to gravity. Actually, acceleration due to gravity, it means if we drop any body, if we drop any body like this, if we drop any body like this, it means initial velocity of the body is equal to 0. Then the body will acquire its velocity on. Then the body will acquire some velocity. Here the velocity of the body is equal to 0. After some time the velocity of the body will be equal to 9.8 meters per second. It means here after some time, it means after 1 second. Okay, when a body is released from some height, the body starts gaining its velocity at the rate with the rate 9.8 meters per second in 1 second. It means the body will add its velocity 9.8 meters per second in 1 second. In every 1 second, the velocity of the particle will add by 9.8 meters per second. Actually, this 9.8 meter per second is the calculated, it means this is the experimentally calculated value. Okay, so this is known as the gravitational acceleration, because earth applies some force on the body, and due to this force an acceleration is generated in this body, and this acceleration is known as the acceleration due to gravity. When this acceleration was calculated, then the value of this acceleration was come out to be equal to 9.8 meters per second square. Okay, so here when we read that when an object falls towards the earth, there is a change in its acceleration due to the gravitational force of earth. Okay, so this acceleration is called the the acceleration due to gravity. The acceleration due to gravity is denoted by small g. Okay, the unit of small g is same as the unit of acceleration, meters per second square. Okay, so actually the value of the unit of gravitational acceleration was asked in SSC CGL 2016 paper, and this question was also asked in an exam conducted by Haryana State, okay, as SSC actually in 2016. Okay, and the same question was asked by the Rajasthan government in REET exam. REET is an exam, this is conducted by the Rajasthan government for the teachers recruitment. Okay, so in the same year. So that's why this unit is very, very important, and you will, and please don't get confused between capital G and small g. Capital G is universal gravitational constant, but small g is the gravitational acceleration. Okay, so mathematical expression for small g, actually this is not needed for your exam. Okay, so don't worry about that. Yes, factors affecting the value of g, this is important. Factors affecting the value of g. First of all, I would like to tell you one thing, that when we talk about the weight of the body, weight of body, actually this is, suppose that this is earth, and this stone has been placed here. So what is the weight of the body? Actually, suppose that a man wants to pull it above. Okay, then he has to apply some force. But we all know that earth is also attracting with some force actually. Okay, this is the gravitational pull. So the man has to apply at least equal to the force of gravitational acceleration, so that he can just pull this body above. Okay, so this pulling force is equal to actually the weight. This pulling force is equal to known as the weight, and this force is always equal to the gravitational force. Okay, so the weight of the body, this is equal to the gravitational force. And the gravitational force is equal to the m into g, where m is the mass of this body, and g is the gravitational acceleration. So the weight of the body can be written as w is equal to m into g. Okay, so guys, if the value of g increases, then the weight of the body also increases. Okay, mass, this is a very important quantity, I will discuss later. Okay, so These are the values. Now let me discuss about the mass. When we discuss about the mass, what is mass? Actually, mass is nothing but the quantity of material of a body. Quantity of material of a body, that is known as mass, and the unit of the mass is kilograms. So when we talk about the mass, we can write it as the quantity of material. Quantity of material. Quantity of material of a body is known as mass of body, and its unit is kilograms. Okay, its unit is kilograms. So mass, when we talk about the mass, mass is a scalar quantity. Mass is an scalar quantity. Mass is a scalar quantity. Mass doesn't have any direction. This mass contains only magnitude, and this is the reason that mass is a scalar quantity. And in some exams, the nature of this quantity is asked. Okay, so you will have to remember these things, memorize these things, that the quantity of type of the quantity of mass is the scalar quantity. Okay, so this is the mass, and the main difference between mass and weight is weight. As I have already told that the weight is nothing but the attraction force applied by the earth on the body. The attraction force applied by earth on the body towards its center, is known as weight of body. So guys, here we can see that weight is a force, but the quantity of material of a body is mass. Okay, and hence the unit of weight is Newton. Unit of weight is Newton. Okay, and the unit of mass is kilograms. Always remember that mass doesn't vary with the variation in the position of the body. Suppose that there is any body that has the total mass of 1 kilogram in Delhi, and it will also be equal to the same mass at in Kolkata also, or whenever you weigh in London, then it will also be equal to 1 kilogram. Okay, if you carry that body to the moon, then on the moon it will also be equal to 1 kilogram. So the value of the mass doesn't change with the change in the position of the body, but the weight of the body changes. Okay, but the weight of the body changes with the change in position of the body. If the weight of the body is maximum at poles on the surface of earth, but the weight of the body is minimum on equator on the surface of earth. Okay, so just because here we will write it as mass okay, mass of a body does not change. Mass of a body does not change with position. with position. Mass of a body does not change with position. Okay, mass of body remains constant with position, irrespective of the position, irrespective of position of body. Okay, it means the mass of a body on the surface of earth is mass of a body